All right, good morning, KAP students. Today is Wednesday the 5th. This is our warm-up on the board, so if you just pause and write down your thoughts and opinions on these questions, we'll go over them in a second. All right, so they're talking about a car. 1 year was $12,000, and then it went up to $28,000. So what was something you noticed, Vivian, about the situation?
The price went down, up.
Okay, good. The price went up. The price went up. Did anyone notice anything else? It's probably just the same thing in different words.
Yeah.
It increased. It went up. Okay, what happened to the cost? Okay, same thing probably, right?
Yeah.
Okay, the price. Could we be more specific? It went up how much?
By
$16,000 by $16,000. That's like more than double its price, right? That's like double and more. And you're like, well, 2.33. Okay, that's something to notice. Times 2.3, like repeating probably. Okay, what's the same thing as 2 and 1/3? It's the same thing. Okay. You might not have gone that far. Okay, that's a little bit extra this morning, but I think that's fine. Okay, so Michaela, do you think this scenario shows an increase or a decrease? Increase, very good. Do y'all agree? Yeah. Do you think there will always be increases when it's talking about stuff like situations like this? Do you think it's always? Do y'all think it will always be an increase, or could there be decreases in costs? Yeah. What are some examples of like decrease? That's the next one. Where might you see a decrease in cost?
Like, the value goes down, like there's not being.
Okay, value goes down. Something's not, yeah. What else?
When there are like clearances and stuff.
Clearance. Clearance is an example where a thing might go down. Yes, good one.
When you get cheaper products.
Cheaper products, yeah. Well, so yes. When there's less demand, yeah, that sort of goes with the values goes down. I didn't want to say that out loud. When there's less demand, things tend to go down in cost. That day after Thanksgiving, they have a bunch of, on Black Friday, there's usually a lot of good discounts, and another word for discounts, sales. Have we heard of sales before? Yes, 50% off, flashing lights, get it now. Okay, are those examples that we know? Great. Okay, there's other percent decreases that we'll talk about in line and stuff like that, but those are examples for right now. Very good. So this is going to lead us into our lesson today about percent of change. I'm going to pass back y'all's finals real quick, so we're going to take a pause. If you were absent, please talk to your teacher about this and that. All right, here we go. So again, we're talking about percent of change today. Examples of percent of change are like when they increase the price, when they decrease the price. Trying to think, there's lots of examples. Tips, tax, those are all percents of the totals. Has anyone like you've seen your parents and like, oh, let me calculate the tip, math. Okay, have you seen that, witnessed that? I have some friends whose parents believe in pure torture, and they would have to calculate the tax without a calculator, and their parents can make them do mental math because it's like, usually it's like 10% or 20%, and so you can just like do decimals and math and gauge. Maybe your mom be like, Mom, can I calculate the tax? Cool, okay? So the percent of change is going to be a ratio. Okay, and as we know, a ratio is comparison to numbers. It is a ratio that compares the amount something changes, the amount something changes we're going to compare that to its original amount. Okay, it's a ratio that compares the amount it changes to the original amount. Now in a ratio, does that order matter? Yes, it does. So on the bottom, which one's gonna go on the bottom? If I'm talking about a fraction ratio. What's the denominator in this case? The what? It's a ratio that compares the amount to the original amount. It's the change to the original. So maybe that's, yeah, I didn't even look at anything. So I'll come back to that question so we can answer that again. If the original quantity is increased, it's going to be a percent increase or a decrease, y'all think? If it increases, it's going to be a percent increase. Are we awake this morning? No. Sing our ABCs again if we really, really want to. Okay, yes, there you go. The original quantity is decreased. It's going to be called a percent decrease. Okay, so let's look at an example so maybe you know what Ms. Huddle's talking about a little bit more. She's being a little weird right now. Okay, so let's look at number one together. We'll come back to that hint, but let's look at an example together first. It wants to know what is the percent of change in this situation and did it increase or decrease? So it says we're going from $8 to $10. If I'm talking about, like, if I need to look at how much it changes, the original amount, let's first start with which of those is the original amount, $8 or $10, class? 8 is the original, and then I like to label my $10 as my new, okay? My original, and that's my new. Maybe I can put like the word original, sorry, let's help me out. Original and new. Okay, if that's my original and that's my new amount, what is going to be my change in those values? Amounts, like money. What is the amount? $2. Okay, so I'm going to put, I'm going to start using a symbol. Okay, I'm going to write change is equal to $2. Another way that you're going to start seeing it, especially in my class, I use the symbol of a triangle to mean change. The change is $2. Okay, because I don't like writing out the word change a lot. The symbol, the triangle, is also known as delta. Okay, that means change. When you find, like, in science class, you find, changing temperature. Sometimes you'll start using, like, a triangle to represent change. So, just letting you know. So, let's do it with the proportion down here. We're going to come back to this example. In this setup, it says that to calculate my percent of change, I do a ratio of the amount it changes to the original amount. So that means when I set up my proportion, I'm going to put the change over the original. I'm going to go ahead and put those labels. Please put the same thing. Again, that triangle means what? Change. Very good. Okay? I'm going to put change over original. And that's going to be the case for all percent of change problems. Okay? My change in this case was how much money? $2 over my original amount of $8. I'm trying to find the percent of change, so on that other side, I need to put what number where? Oh, what was that? If it's a percent, on the other side, I need a 100, and it's going to go on the bottom. Very good. Okay? And the way to remember that, your original amount is always going to be 100%. Okay? Because if it's a sale, that's less than 100, but that original amount is always going to be 100. And hey, look, it's a proportion. It's always there. I like the up and down way in this case because to go from 8 to 2, I need to divide by 4. So over here, divide by 4. X is going to equal, and not just 25, but 25%. 25%. And was it an increase or decrease? Increase. Very good. Making sense? Slowly but surely? Okay. So this thing above, this is called the bar model. Some of y'all have seen this in elementary school, some people not so much, but it's helpful to some people really visualize percent of change. Okay. So I noticed that there's like this square here, and then there's like the dotted around it. Y'all see the difference between those two? Okay. So what's going to happen is I'm going to say this little dotted part is the stuff that was added on. I'm just going to let you know beforehand. So what I'm going to say is on the top, I'm going to be talking about percent, and on the bottom, I'm going to be talking about money. You can either follow along or you can just watch me for this one. When I have $0, that's going to represent 0%. But in this case, if I want, this is my full box, again, this is ad hoc, but my full box, that would be 100%. The 100% again represents how much money?
$100.
Not $100, it represents $8. Okay? Now, I know from my problem, if the way to use the bar model, if I don't know my answers, is this is how I do it. I say, okay, my original was $8, but then it went up to $10, and that amount of change we said was $2. What I'm trying to figure out is what percent of change that was. Okay, what percent of change that was. If I'm trying to figure this out, I need to see, okay, what percent is $2 of 8? So I'm actually going to go off a little bit. I don't like that it has the squares in there, so I'm going to show you differently. Same thing. This is talking about percent. This is talking about dollars. We said 0%, $0. This is $8 was 100%. Are we good with that? Okay. We said that we added on $2. That gave us $10, but I don't know what percent that is, and I don't know what percent change that is. So what I'm going to do is I'm going to break this 8 into $2. How many times can I break 8 into $2? 4 times. So I'm going to break this into 4 sections. Again, that's going to represent $2. That's going to be 4. That's going to be 6. Are y'all good with that? Okay. If I have 100 and break it into 4 boxes, how much is going to each one represent? 25%. Very good. Okay. 25%. 25%. 25%. Therefore, if I add on another $2, that means I'm adding on another what percent? 25%. Okay? Y'all see that's a different way to do it? Okay? For some of y'all who are more visual learners, maybe the box method is your way to go, but if proportions is like, oh, that makes a lot of sense, like that's straightforward, that's your go-to. Okay? Let's just do one more together. I'll start with the bar model and then go to the proportion. Okay? So starting in number 2, what is the percentage change? Did it increase or decrease? So first, let's look. Which one is my original? Which one is my new?
Original 10 and new 8.
Very good. Original to new. Very good. Okay, so I'm going to do percent over here and dollars down here. I already heard some of y'all say, is it an increase or a decrease?
Decrease.
Decrease. I'm going to go ahead and put that in my answer box. Let's not forget it.
Okay, now this is the exact same thing I'm talking about, but opposite.
It is. Very good observation. It is like just a switch. Okay, let's see if it's going to give us the same answer. I want to know, is it going to be a 25% decrease? Let's look. Okay, so on this one, because I'm starting at the bigger number, my full thing, that's going to represent 100%. Okay, and this is going to be, what was the original cost? $10. Now, if I went down to $8, what's that change? The change is still $2, okay? So that's still $2. How many times can I break 10 into 2 sections? 5 times, so 2, 2, 2, 2. Do y'all agree with all that? Yes. So if I break my 100 into 1, 2, 3, 4, 5 sections, what percent is each one going to represent? 20%. This one's going to be 20%.
So are we getting the
That's correct. Okay, because we went down $2, we went down 20%. So that was a 20% decrease in this problem. But it's flat, right? So like, why is this one 20 and the other one was 25? Let's keep going. Let's look at the proportion. When I set up a proportion for percent change, I always put what over what? I always put change over original. Very good. I'm going to put my change over my original. What was my original in this case? 10, and my change was? I need to put a 100 over here, and then I'm solving for x.
Is it because there we needed to add in there we go?
That's part of it. That's not the full reason. Okay? Do y'all want to go up and down or side to side? Up and down? Does it matter? No. Okay, what do I need to do in this case? Divide by 5. And that gives me, 20%. Okay? So let's look at that fully. What in that caused this to be 20% versus 25? What were similarities and differences that we see? Raise your hand. What are similarities and differences? What do you notice?
Because this one, the order was 8. And this one is 10.
Very good. The original in this one was 8, and the original in this one was 10. What else do y'all notice? Is the change the same? Like the dollar amount? Yes, but because of that original amount, because of your original value, that's what's changing that percent. I was starting at 10 or I was starting at 8. That's the whole big thing. Okay? So that's what made the difference, and that's why it's super important to label and know what you're starting with and what you're going to. Okay? So a little helpful hint, now that we've had our brain wrapped around, the original amount is always proportional to the 100%. It always goes along with that 100%. Okay? So I'm going to get you set up on one more, and then I'm going to let y'all try a couple. Are we good to go to the next page? Or no, not the next page, but this one. Okay, so we need to figure out what is the percent of change from 10 yards to 13 yards. So I want to rewrite it like they did up here, the $8 to $10. What would I write for this one? 10 yards to 13 yards. Okay, so again, this is my old or my original. Original. Exactly. This one is not old at all, and this is not it. Okay, then right here, this is your bar model. Okay, I'll just write the bar model, but you can figure it out in the proportion and then answer. Okay, try these next two on your own. Check with your table mates, sort of talk with them if you need to. Pause at home and play when you're ready. Here we go. You might be done, you might not, but I'm going to go ahead and go over. So, in a proportion, I put what over what in percent of change? I put?
Change over original.
Awesome. Change over the original. So in this one, my change was
3
over 10. I need to get that to 100. I like this way times 10. That gives me 30. So it's going to be a 30% increase. Very good. If you did the bar model, 0% represents $0. I'm starting at 10, which represents 100%, but then I'm adding on $3. I need to figure out what that change is. Okay? If I can't break it into threes, can I? It's not going to work out. So instead, did someone figure out what you could break it into instead? Okay. I can break it into ones, right? I can break. I don't even know how many times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Each one represents $1. That means each one's going to represent. Say louder. 10%. So that means I can't just add on 3, really. That's weird, right? Okay, I need to add on, if I'm adding on the same amount, if I'm adding on another 1, 2, 3, that's going to be another 10, 10, and 10. So in total, that would be 30%. That bar model is a little different, but maybe it makes sense. Okay, what's the rewrite on this one? Raise your hand. What's the rewrite? It went from this to this, dude. 160. That change was how much money, class? Let's try that one more time, class. How much was my change? $32. So in my proportion, I put what over what?
32 over 138.
Thank you, sir. And class, what label am I going to put over here?
Original and
Let's try that one more time. I put Okay, let's put it in the original. So, one more time in the correct order. I need to put. I love the excitement, but let's do it correctly over here. 100 and X. Now, this one got spicier. How did I do it? How did someone do it? What did you do, Michaela? You found the scale factor this way, okay? And what did you find? Divide by 4, okay? Divide by 4, divide by 4, and that would give you 0.25, right? Okay, sorry, I heard 5. Did anyone do it a different way? You simplified it. Class, can we simplify?
Yes.
Absolutely. Devani, what did you simplify by?
I did it divided by 8.
You divided 32 and 128 by 8. Great. And what was your new simplified fraction? 1 over when you simplified it all the way down. So technically, if you divide them both by 32, that's what you would get. And then do you give that same percent? Very good. Okay, so that's going to be a 25% increase. Is this making some sense, guys? Minimal, at least. Okay, we are going to spend the rest of the week on percent of change because sometimes this does take a little time to digest, which is fine. Okay, what's going to happen? We are going to do a Kahoot so we can have some fun and some practice. That vampire page that you picked up is your homework tonight. You will turn in tomorrow for a homework grade. Okay, questions on that? Sorry. Great. So you got the other half for homework tonight. So let's go ahead and play this Kahoot. Y'all can grab devices. If you're at home, your link is on campus, and you can check your vampire on your